Hello. Today we're going to talk about the graphs of some trigonometric functions. We're going to talk about the graph of three trig functions. We're going to look at y is equal to sine of x, y is equal to cosine of x, and then y is equal to tangent of x. We're also going to talk about translations of these graphs and talk about some peculiar aspects of sine and cosine, right? Strange aspects of sine of x and cosine of x. All right, we're going to look at the graph of the function sine of x, right? The graph is going to start at the origin, and the x values that are really important to know are pi over 2, pi, 3 pi over 2, and 2 pi. And the y values we're really going to have to know are going to be 1, -1, and 0. So it's going to start at the origin, come up, cross, and hit down. And it'll just repeat that same shape. This, and it goes backwards as well. Right? So this can actually help us test the values. Right? This is going to be 5 pi, 2, 3 pi, 4 pi. And that's going to be the basic shape of the graph of sine of x. What we can see is trig functions are what we call periodic. And the reason they're called periodic is because the graph will repeat after a certain time period called a period, right? And the period for sine and cosine, we'll see, is going to be the length of 2 pi. So one thing that might be unusual, we really kind of haven't seen something like this before. This is one of the strange aspects, is that sine is going to be bounded, right? The output values for sine are always between -1 and 1, right? We never get a sine value bigger than that. So the two ways we can think about that are this inequality, -1 is less than or equal to sine is less than or equal to x, or we can think about it as the absolute value of sine of x is less than or equal to 1, right? Any value of sine, if we just look at the positive values of it, right, that's what the absolute value does, that has to be bounded by 1. Right? Next, like we said, we're going to look at the value of y is equal to cosine of x. And sine and cosine are going to be very similar, right? We want to look at the y values of 0, 1, and -1. And we want to kind of keep the same x values in mind. Pi over 2, pi, 3 pi over 2, and 2 pi. Except now, instead of starting at the origin, this is going to start at 0, 1, come down, come up. And it will again repeat that same shape. Like this, and it will come behind as well. Like that. Right, this should be a little curvier. Right, and again, we can see the period of this graph is again 2 pi, the length it takes for it to actually repeat. And again, cosine's strange, peculiar aspects is that cosine is also bounded between -1 and 1, right? It hits its height kind of right at the start at the point 0 and hits its low point at pi. And we can also say that the absolute value of cosine of x is less than or equal to 1 as well. Right? The last graph that we want to know kind of the basic shape of is tangent of x. And tangent of x is going to be very kind of weird. Pi over 2, -pi over 2. And one of the weird things we said was that we looked at two values a lot. Tangent of 0, we said that was 0. And tan of pi over 2, we said that was undefined. So it turns out that tangent will have what we call vertical asymptotes. Right? We're going to define them later in a section. And what it will do is tangent will always kind of look like this. It will still keep the same basic shape going through, but it will have all these infinitely many breaks at the different pi over 2. It's like pi over 2, 3 pi over 2. This is negative 3 pi over 2. And it will keep repeating like this. The period of this is now just pi, right? And this is unusual because tangent of x is unbounded, right? There is no value that tangent is always going to be bigger than or smaller than, right? We see this vertical line here, and that line goes all the way up to, but not including that vertical line. So actually any value of tangent can be valid. Okay, now that we've gone over the basic shape of these trig functions, we can talk about translations of their graphs. And these will work really the same way. So if we want to try and sketch y is equal to sine of x plus 2, what we'll do is we'll take the basic graph of sine of x, right? Remember that this is 1, this is negative 1. And what we're going to do is we're going to take this graph and shift it up 2 units. Here's 2, here's 3. So the origin gets mapped up here. Right, we'll do this in a different color. We'll do this in green. It's mapped up here. This high point gets mapped up here. Right, we're going to go down. The low point is here. And go back up. Right, and that's really the best way to start to translate these graphs, is to only work on one period, only work until it repeats, and then we can keep the same basic shape. Right? Kind of like that. That's how we would shift this translation up 2 units. All right, so let's look at another translation. Right? We're going to sketch y is equal to cosine of x minus pi over 4 plus 1. Right? And so this is different for a few reasons, right? Now we have a horizontal translation, right? This is shift to the right. And not only are we going to shift things to the right and left, but no longer are we shifting to the right or left by something like minus 4 or plus 12. We're going to be shifting to the left or right by factors of pi. Right? All of the x values here for trig are going to be values of pi. So that's what we want to shift by. Right? So what we can do, again, is start to look at what our graph basically looks like before any shifts. Right? And cosine, we said, kind of looks like that from one period. Right? We start at 0, we go to 2 pi, here's pi. Right? But now we're going to shift all of these points up 1. Right? And not only are we going to shift them up 1, but we have to shift them to the right pi over 4 units. And so the question is, when we have a graph like this, where would pi over 4 be? Where does this point really get mapped to? And so we said that each of these kind of x dashes would be a unit of pi over 2. And so it turns out that halfway in between these are all the pi over 4 units we're going to go. So our graph doesn't just get shifted up this way, it actually gets shifted up and to the right a little bit. So it'll come out looking like this. Right? That would be one period of the graph. Sorry. Like this would be another. And so on. That's how we would deal with horizontal shifts. All right, let's do another example. We'll try and sketch y is equal to 2 sine of x minus 1. Right? And so again, we can look at the basic shape of sine. Right? Here's the one period of sine. Right? This is pi over 2. This is pi. This is 3 pi over 2. And this is 2 pi. Right? And we know the 1 is going to shift everything down 1 unit. Right? Here's -2, here's -3. Right? That's 0, that's 1. But again, what does this 2 do? Right? There's a term we want to talk about when we deal with trig, and it's called amplitude. Right? And amplitude is going to be how high our graph goes. So we can see that the amplitude of a normal trig graph is just going to be 1 unit, because from this horizontal line it goes 1 unit up, and it goes 1 unit down. But what this 2 does is it changes the amplitude. And what it's going to do is it's going to do exactly what it did for regular translations of graph. It's going to stretch the graph vertically, and it will change our amplitude by exactly that factor. It will change our amplitude exactly by a factor of 2. So we can take this in steps and say, well, what would the graph sine of x minus 1 look like without the change of amplitude, right? Everything here would just get shifted down 1 unit. Right? This horizontal line would become y minus 1, and everything would kind of be moved down. But now, if we want to sketch 2 sine of x minus 1, right, all of these points would be the same. All of these points on that horizontal line, y equals negative 1, would be the same, but our amplitude gets changed. So instead of being 1 unit high, it's going to be 2 units high. Instead of being 1 unit down, it's going to be 2 units down. So the graph gets much more dramatic. That would be one period. So if we wanted to continue this, go up, down, like that, and the other side, go down to, back there, up to, and so on and so forth. So that 2 actually really stretches our graph out. Okay, let's do one last example, and it's going to talk about how we deal with reflections of the graph. And so we want to just simply sketch y is equal to negative cosine of x. And so if we remember just regular cosine of x, right, 1, negative 1, here's pi, here's 2 pi, and just regular cosine of x looks like that. But what a negative does is exactly the same thing as it does before. A negative on the outside of our function flips vertically. So what it's going to do is it's going to take all of these points and flip them. So our graph, kind of finished off in green, would be exactly the same shape, but the opposite. And we can just continue the same shape. Right? And that would be the graph. Let's clean this up. Right? That would be the graph of cosine of negative cosine of x. All right, I hope this was helpful. If you have any questions, feel free to ask, and we'll see you guys in class.